Hi everyone. So this afternoon what we're going to be doing is we're going to be looking at some more Earth and space for our science work. And today we're going to be doing flow number 4, which is really going to focus on day and night. So key questions from today's learning is what causes the change between daytime and nighttime. What we're looking at here is what's different during the day and what's different at the night and what causes those things. Why do we get both of those things? So to do this, I want you to obviously follow this assessment checklist, which says I can use the idea of the Earth's rotation to explain day and night. So that's going to be a key aspect of our learning, and be able to explain why the sun appears to move across the sky. Because if we look outside during the day, not at the moment because it's a bit doom and gloom out there all the time, but if you think about a summer's day, how the sun seems to move across the sky. We're going to be thinking about why that happens and if actually does it happen? Is it the sun that's moving? So, a few key facts to start us off. So the Earth orbits the Sun, and this takes 365.25 days, so 365 and a quarter days. Now you're probably thinking, how can we have a quarter of a day? That doesn't mean that some days we wake up in the morning and all of a sudden we go, oh, we're only going to have a quarter day today. You might be familiar with something called a leap year, which happens every 4 years, which is where we get those quarter days added together. So in February, every 4 years, we get an extra day, and that's known as a leap year. And that's where we get those quarter days back. And that stops us having to have a sort of a ruined calendar after thousands of years. So we still get 365 days, 3 years in a row. And then that fourth year is where we take into account those quarter days. The second fact, the Earth rotates on its axis, and one of these rotations takes 24 hours, what we would call a day. So there's 24 hours in a day. I'm sure you've heard that before. And this is that key piece of information. Another fact, shadows are formed when light from a source is blocked by an opaque object. So when we did our light sessions and we used the torches, you remember there were 3 different types of things that were happening. So we had our opaque, we had our translucent, and we had our transparent objects. And here we're thinking about the shadows that are formed on the Earth by obviously an opaque object. So what I want you to do, and obviously you can do this in your own time, I want you to answer this question here and think about why is light so important to us. And if you just jot down that on a Google Doc and send it over to your teacher, or if you just bring that back, if you make a comment, if you've made a copy of the slides or add it on Class Dojo, that'd be fantastic. So obviously we've seen this image before. It's an image of daytime, and you can see sort of in this track of how the sun appears to move across the sky. Now, hopefully you've seen something like this before, and as the day progresses, obviously we have sunrise, and across the day, obviously the sun appears to go across the sky, and as you can see here, it seems to be getting higher in the sky, all right? And hopefully what you're going to be able to do by the end of this lesson is understand why that seems to happen. Okay? Think about those things from our assessment checklist, and try and apply those when obviously we've got that knowledge. Some key words that you'll be using. So this is really important when we get to things like our thinking, explaining, and solving tasks. The key vocab that I really want to see in your writing is obviously day, night, because obviously they're key important, shadow, sundial, and that'll be important later on when we talk about solving, clock, because the time of the day really plays a key part in that, and that ties back into this sundial here, which you might have seen before, but as I said, will be really important when we get to tasks later on in this session. This slide just shows you sort of a countdown and a clock throughout the day, and this should really give you an indication of where daytime and nighttime is at different times sort of across the globe, across the planet, because obviously we've talked about before when it's sort of daytime in where we live at the moment in England. In different parts of the world, it's nighttime, and that's all to do with the Earth's rotation, which is that thing that takes 24 hours. So everyone is still getting that 24-hour day, but at different times, obviously, they're experiencing nighttime, and that's all to do with the hemispheres of the Earth, which again goes back to a lesson that Mrs. Wood did with you about the different hemispheres on the planet. So, quick checkpoint. And again, if you just jot down the answers to this, we will go back and check these in a few minutes' time. But just as you go through, it asks you to change one word in the sentence to make them correct. So all you have to do is rewrite the sentences carefully, thinking about the knowledge you've acquired so far, and any further information from your own research. So it says the Earth is at the center of our solar system. Now, we did do some work with our top trumps cards about different planets in the solar system. So really, that should be a nice, easy one that obviously you can rectify, because obviously we know that one's not quite correct. So changing one word in that sentence, what is at the center of our solar system? Question number 2, it takes 24 hours for the Earth to orbit on its axis once. Remember, Earth orbiting on its axis is that rotation of the Earth, okay? And the axis is that point where it rotates. Question number 3, sunlight can only shine on 1/4 of the Earth at a time. Okay, so think about what we've done with fractions. What is 1/4 of the Earth? Go back to that diagram that we just looked at. That should give you a really big clue. So maybe that fraction isn't quite right. Question 4, when the sun is visible in the sky, it is nighttime. Okay, think about that question carefully. And I know for some of you, you've probably seen the moon during the day. And have a think about why that is. If you can explain that phenomenon, again, just put it onto a Google Doc, send it over to your teachers. We'll be really pleased to see those. In the morning, the sun rises in the west. Now, no matter what you've seen on some things, there is a key bit of evidence, a key bit of information that's not quite right there. So have another look at that. I'll give you some time to do that. So if you don't want to know the answers straight away, obviously just click pause on this video now, because I'm going to reveal the answers shortly. So hopefully these are the answers that we were getting. So obviously Earth should be sun, orbit should be rotate, quarter should be a half, nighttime should be daytime, and west should be east. So just like we do in our math sessions, make sure you give yourself a star if you get any of those correct. And again, just send them over to either myself or your class teacher, and we'll get some dojos added on for you for getting those correct. So now I'm going to talk about now is our independent task. So what I'm expecting you to produce this afternoon. So the first thing I'd like you to do, and I will share some resources in the Google Classroom for this, is to draw a diagram or make a model to explain the sun's apparent movement across the sky. So we saw this diagram a bit earlier on, but now I want you to think about why this happens. Why does it seem to do this? So what I'd like you to do for that is, and you can make a model, and as I said, I will send you the resources for that. Or if you just want to create it again as a Google Doc or a Google slide, just to show that and really explain it, you could even add your own voice onto that to give it obviously a clear explanation, or you can do it in written form or using pictures, whatever you find the easiest. But again, make sure you share those with your teachers. Once you've done that, I'd like you to research some of these things here. So what is a time zone? Again, think back to that lesson with Mrs. Wood that you did about hemispheres, and you looked at the different lines of longitude and latitude on the Earth, and that will really, really help you with that question. And again, it is research, so anything you find, try and put into your own words, because that will really master your understanding. Next question, why is time not the same everywhere on Earth? Again, think back to that question where we looked at the different hemispheres, what's happening in the northern hemisphere, what's happening in the different hemispheres, and then think about how that changes across the planet. Next question, what is the dateline and international timeline? Again, we've done lots of work on this before where we've looked at different time zones. So what are these? What are these particular things? Explain them. Where are these places and why are they here? So why do we have the dateline and international timeline? What do they do? What's their purpose? And really add that. And be as creative as you want with that. It can be a poster, anything you want, just to represent that information, to really, really demonstrate your research. So if you've got all of them correct, or if you've got time, obviously we've got our thinking, explaining, and solving tasks. So for the first one of those, it is a convince me. So try to add an explanation to this. And it says that whilst it is day for some people on Earth, it is night for others using this diagram. So again, we've talked about this earlier on, but have a real think about how the structure of the Earth, and obviously when we're looking at this slide, if I shoot back to it, this one here, really think about what does that show us? How are people experiencing different things? What's causing this? Why is one half of the Earth experiencing daytime while the other half experiences night? Really try and be clear in that explanation, because it is a convince me answer. So again, if you want to use diagrams, if you want to add that diagram to what you've created already, then by all means, that would be great. Once you finish that, there is another thinking task, and it is an always, sometimes, never. So you're sort of picking the odd one out here and saying, is it always, is it sometimes, or is it never? The sun always rises at the same time. Now, you might be thinking, oh yeah, obviously it does. It rises before I get to school, and then it sets before I get, when I've had my dinner, before I go to bed. But think about how that changes across the year. Do we experience longer days at different points in the year? Do we experience shorter days at different points in the year? Does the weather play a part in it? I don't know. So have a think about, is it always, sometimes, or never? Once you've done that, your explaining task. And here it says Sally, we could have Dr. Spartacus, it doesn't matter. But it says, Sally says that in some places in the world, they experience 24 hours of darkness or sunlight at different times throughout the year. Is she correct? And explain why. I did watch a great documentary about this. So if you are into documentaries, especially Attenborough, he was a bit of a hero of mine. There is a great thing about that where he looks at, it's called Frozen Planet. So if you do ever want to check out that, he talks a lot about obviously that, and that should give you a clue as to where these places happen. So think about the poles, North and South Pole, when you're thinking about the answers to this question, and obviously the areas surrounding them. So again, you will have to research that. But think about, what would it be like for those people if they did have to live in 24 hours of darkness, or at good times 24 hours of sunlight? What would you be able to do? What wouldn't you be able to do? And have a think about that. Final task, so your solving task is a little bit of making. So again, you're going to be quite creative, and I would love to see some working ones of these. So again, by sharing them on Google Classroom or on Class Dojo with your teachers, we'd like you to create a working sundial. I was going to say Venn diagram. It's not a Venn diagram. It's very much a sundial. So again, some of these use Roman numerals. So when we've talked about in our Roman numerals lesson, where do we see Roman numerals? This is a key example of where we see them. I talked a lot about them having them on posh clocks, but a sundial is another place where we'll see Roman numerals, and that's to do with the history of them. So you might want to find out about that as well, how they've played a part throughout history in helping people tell the time. And that ultimately is what they do. They use the sun to help us tell the time. So what I'd like you to do, please, is to create one of those, and you can use anything at home. It doesn't have to be something you can bring in. It can be something on the floor. It can be in your garden. It can be junk modeled with any bits of recycling you have. Or as I say, if you can't do that, you might just want to create a poster that explains the history of sundials. And again, make sure you're sharing those with your teachers, because we do love to see these things. So hopefully that gives you a bit of an outline of the tasks. As I've said previously, I will share lots of these resources with you. So make sure you check out the Google Classroom for those. There will be some accompanying videos to specially help you with the fluency tasks. And again, they'll be shared in the Google Classroom with you. But please, please, please share this stuff with us, because we do love to see the work that you're getting on with at home. So hopefully that clears lots of things up. Hopefully you enjoyed that, and I'm looking forward to seeing your work. Thank you very much.